Okay, so here's the intro video for volumes by cylinders or cylindrical shells. The example I want to use to motivate this idea is the same sort of example I used for the disk intro video, except in the disk video, we rotated it around the x-axis. In this video, I want to rotate it about the y-axis. Before I talk about any of that, though, I want to make sure we understand what this shape looks like. The shape that we're trying to do is in blue. I'm taking this region here, and I'm rotating all of that around. So it's in blue. So this purple bowl thing is not in it. But this sort of, I can create a mirror image on the other side, and it's sort of circular like this. And it goes, not the best at drawing it. I think the picture on the left is way better. I hope you can sort of visualize what it would look like rotating that area around the y-axis. Notice that it's sort of not easy to do this with the methods that you know right now. But if you think about splitting up the area in a little bit of a different way, then it is very doable. So I'm going to redraw the axis because I had a bunch of extra stuff there. Here's my parabola. When we rotated about the x-axis, we took some kind of rectangle down, and when we rotated that down, we got a big cylinder. And then all we had to do is add up all of those together. But now that it's about the y-axis, I've got this, space here that doesn't have anything in it. So I have to be careful about that. The way that I want to think about this is breaking up at every point. Let's say this is an x value. I'll just call it, I don't want to call it x. Some predetermined value, let's say a. If I draw up an infinitely thin rectangle at x equals a, what would that look like if I rotated that about the y-axis? I would kind of get a super, super thin cylinder, like hollow on the inside. It would be a cylinder, but only like this outside super thin part. None of the inside. I hope you can see that. I'm not the great artist. I'm not a good artist, but, make do with it. So think about what the volume of one of those little cylinders is. Well, think about it. Let's see if we can get the dimensions of this cylinder, and for that I'm going to draw it bigger. So we have this cylinder, and I'm only taking a little outside sliver. So I'm only taking everything outside this purple. So it's on the outside here, it's on the outside here, etc. Think about cutting this on the edge and then unrolling it. Unrolling it like it's so then it becomes a rectangular prism. So I'm going to draw in green. I should dot it. So I'm saying I'm cutting it here. I'm going to dot in green and saying I'm going to cut the shape here. So if I do that, I get like a rectangular prism. That's horrible. I know how to do that. Do that better. Okay, so what are the dimensions of this? Well, the really thin part is this infinitely small delta x. It's that super width, let's say delta x. The height of this cylinder, the height is just the height of this rectangle. That's just the function. And then the length of this rectangular prism, well, isn't it the circumference around the entire cylinder? Because then when I chop it off here, that'll all unravel, and it'll become a straight line. So this is the actual circumference of the cylinder, which is 2 pi r, because the circumference is 2 pi r, but the radius of this circle, what's the radius of this circle? Isn't the circle, if we go back to the actual picture, isn't the actual cylinder, like, it looks like this. So the radius of this cylinder is actually just the x value. I'm so bad at drawing this, I know. I'll stop saying it, but so the radius of this is the actual x value here. That's how far to the right I have to go. So this is 2 pi r, which is 2 pi a. So the volume of this entire solid is going to be the integral. I'm adding up all of the possible rectangles. So I'm adding up at every x value. I take the volume of a cylinder centered there. So I'm adding up on the interval. My interval is 0 to 1 here. I'm adding up 2 pi x value times the function. Adding up a bunch of cylindrical shells. This would be like taking the original shape. It's a better way to visualize it. For a different shape, suppose the volume I want is a cylinder without the cone inside. So it's like it's circular, so I'm not drawing it with straight lines well. But this volume inside is what I want. The way I'm breaking it up is I'm breaking it up like this. I'm slicing it sort of horizontally and taking a bunch of hollow cylinders and cutting up the volume that way. I encourage you to look at the book, which has much better pictures than I do. The book has nice printed computer generated pictures of this. If my drawing is too bad to help you understand it, but I hope you do understand it. That is where this formula comes from. And we're going to be using that in the next couple example videos.